The History of Measuring Time. Introduction to the Concept of Time. For much of human history, time was understood through observation of the natural world. Ancient societies relied on the rising and setting of the sun, the changing phases of the moon, and the shifting constellations to guide their lives. Seasonal changes dictated agricultural practices, and the cycles of day and night structured daily routines. While this natural timekeeping was sufficient for simpler lifestyles, the growth of civilizations introduced new complexities. As cities expanded and trade networks grew, a more systematic and reliable method of tracking time became necessary. The need to coordinate activities, schedule tasks, and manage communal events highlighted the limitations of relying solely on celestial patterns. Over time, the evolving demands of society paved the way for innovations that would redefine how humans interacted with and understood time. The birth of mechanical clocks. In the 1300s, European monasteries became the birthplace of mechanical clocks, intricate devices that fundamentally changed how time was tracked. These early clocks relied on complex assemblies of gears, weights, and escapements to measure the passage of hours. Unlike modern clocks, they did not account for minutes or seconds, but were instead designed to align with the daily schedules of monastic life, particularly the timing of prayers. Their towering structures and mechanical precision made them both practical tools and symbols of human ingenuity. The creation of these clocks was not solely about practicality. It represented a shift toward a more structured understanding of time. As the technology spread beyond monasteries, it began to influence broader society, laying the groundwork for future innovations in timekeeping. The advent of pendulum clocks. Galileo's observations of pendulums in the 1600s revealed a fascinating property. Their consistent, regular swings made them an ideal mechanism for measuring time. This discovery laid the groundwork for a technological breakthrough in timekeeping. Building upon Galileo's work, Dutch scientist Christiaan Huygens designed and built the first pendulum clock, transforming the accuracy of clocks to a level previously unimaginable. The pendulum's steady oscillations allowed these clocks to measure time down to the second, a significant leap forward from the hour-focused mechanical clocks of earlier centuries. Huygens' invention was revolutionary for its ability to track time with unprecedented precision, losing only seconds in an entire day. This advancement fundamentally reshaped how humans engaged with time, offering a reliability that had not existed before. With pendulum clocks, society began to move toward a more standardized approach to scheduling and time management, aligning personal, communal, and professional activities with greater synchronization. The impact of this new technology was especially transformative for fields that depended on accuracy. Navigation, for instance, saw dramatic improvements, as sailors could now calculate their positions with far greater confidence using timekeeping as a critical tool. Astronomy, too, was deeply influenced by the invention, enabling astronomers to make far more detailed observations of planetary and celestial movements. In many ways, the pendulum clock became a cornerstone of the growing scientific revolution, facilitating advancements across disciplines that demanded precise measurements. Additionally, pendulum clocks set the stage for a broader cultural shift. Time became something that could be more finely divided and measured, fostering a new awareness of punctuality and efficiency in daily life. As pendulum clocks spread across Europe and beyond, they began appearing in homes, businesses, and public spaces, signaling a shift toward a society increasingly governed by the precision of the clock rather than the rhythms of nature. The transformation of society. The increased precision in timekeeping introduced by innovations like pendulum clocks brought about significant changes in how societies functioned. One of the most notable impacts was on daily life and work. With the ability to measure time more accurately, people began structuring their activities around specific hours rather than the natural rhythms of daylight and seasonal changes. This shift contributed to the development of more organized schedules, fostering punctuality and efficiency in both personal and professional settings. The industrialization of societies further amplified this transformation. Factories relied on synchronized timekeeping to coordinate production processes and establish shift work. As towns and cities became hubs of industry, public clocks became central fixtures, serving as reference points for entire communities. The regular chime of the clock created a shared temporal framework, connecting individuals to a collective sense of time. Beyond its influence on daily routines, precise timekeeping had far-reaching implications for global trade and transportation. Accurate time allowed ships to determine longitude more reliably, revolutionizing navigation and enabling safer and more efficient sea voyages. This advancement opened up new trade routes, strengthened international commerce, and connected distant regions of the world in ways that were previously unimaginable. Timekeeping also played a pivotal role in the development of modern transportation networks. The advent of railroads, for instance, required standardized time systems to coordinate train schedules across vast distances. This need led to the adoption of time zones, further aligning human activity with the precision of clocks. As railways expanded, they facilitated the movement of goods and people on a global scale, reinforcing the importance of accurate time management. The widespread use of precise clocks also impacted cultural attitudes. Time was increasingly perceived as a resource to be measured, allocated, and optimized. This mindset encouraged a growing emphasis on productivity and progress, reshaping how individuals and societies approach their goals. Modern timekeeping innovations. From the groundbreaking invention of pendulum clocks to the extraordinary precision of atomic clocks, the evolution of timekeeping has been nothing short of remarkable. Atomic clocks, introduced in the mid-20th century, represent one of the most advanced achievements in measuring time. Unlike earlier clocks that relied on mechanical parts or pendulums, these devices measure time by observing the vibrations of atoms, such as cesium or rubidium. These atomic oscillations occur at incredibly consistent frequencies, enabling an unmatched level of precision. This technology has transformed modern life in countless ways. Global positioning systems, GPS for instance, depend on atomic clocks to provide accurate location data. Satellites equipped with these clocks synchronize with receivers on Earth, allowing everything from navigation apps to aircraft systems to function seamlessly. Without this level of accuracy, even minor timing errors could result in navigational discrepancies of miles. Telecommunications also benefit from atomic clock precision, as data transmission across networks relies on perfectly timed signals. Whether it's coordinating international phone calls, streaming digital content, or managing financial transactions, these applications require synchronization at a scale only atomic clocks can provide. The financial sector, in particular, depends heavily on precise timekeeping to timestamp transactions, ensuring accuracy in high-frequency trading systems. Beyond its practical applications, atomic clock technology plays a pivotal role in scientific research. Astronomers use it to study the movements of celestial bodies, while physicists rely on its accuracy to test fundamental theories about the nature of time and space. For example, highly sensitive atomic clocks have been used to detect the effects of gravity on time, as predicted by Einstein's theory of general relativity. In cutting-edge fields like quantum mechanics and space exploration, atomic clocks continue to push the boundaries of what we know. Their unmatched precision allows scientists to explore phenomena that were once beyond human reach, paving the way for discoveries that redefine our understanding of the universe. Conclusion: the significance of time. The journey of timekeeping reflects humanity's relentless pursuit of progress and precision. From observing the cycles of nature to harnessing the power of atomic vibrations, each advancement has shaped not only how we measure time, but also how we live and think. Time has become more than a tool. It is a framework that governs our personal lives, drives global systems, and underpins scientific discovery. With each innovation, from mechanical clocks to modern atomic systems, timekeeping has bridged the gap between imagination and reality, enabling achievements once thought impossible. It has synchronized societies, revolutionized industries, and fostered a sense of interconnectedness across the world. Beyond its practical applications, the ability to measure time with extraordinary precision reveals the interplay between humanity and the cosmos, grounding us in a universe that is vast yet meticulously ordered. More than a mechanism for organizing daily routines or advancing technology, the pursuit of timekeeping has illuminated our capacity for creativity and problem-solving. It serves as a testament to the human spirit's determination to understand and navigate the complexities of existence. By mastering time, we not only improve the efficiency of our interactions and systems, but also push the boundaries of our knowledge, opening doors to realms that deepen our understanding of the world and our place within it. Time is woven into the fabric of our collective experience, shaping how we perceive progress, prioritize goals, and value each moment. As we continue to refine our ability to measure this elusive dimension, we are reminded that timekeeping is not merely a technical endeavor, but a reflection of our desire to explore, innovate, and make sense of the universe. In this pursuit, we discover not just the mechanics of time, but the essence of what it means to be human.